Welcome to Stage 2 Chemistry. We're starting off with Topic 1 and 1.1, which is Global Warming and Climate Change. In this video, we are looking at first two boxes on Science Understanding table here, which is some gases in the atmosphere called greenhouse gases keep the Earth's atmosphere warmer than it would be without these gases. This is known as the greenhouse effect. What you need to be able to do with that is you need to be able to describe the action of the common greenhouse gases, which is carbon dioxide and methane, to maintain a steady temperature in the Earth's atmosphere. Next thing is anthropogenic increases in greenhouse gases disrupt the thermal balance of the atmosphere. You need to be able to explain the warming associated with global climate change and its consequences for the environment. So those two. Well, let's have a look. In class, that one there. In class, we'll be looking at this TED Ed video on how the country called Bhutan isn't just carbon neutral, and they're actually saying that they will be carbon negative. They are staying and they are committed to stay as carbon negative. It's really good talk done by a prime minister, their prime minister of the country, and yeah, we'll take some key concepts from it and we'll discuss what we can do as, well, Australia, developed country. Next slide, we start talking about greenhouse effect itself and what it is, and you need to learn how to be able to describe the how carbon dioxide and methane gas acts in this. All right. So, firstly, what's going to happen? Of the solar radiation coming from the sun, slightly less than half actually warms the Earth's atmosphere. Where else does it go? It gets either reflected back or absorbed by the clouds or even ocean. The average temperature of the surface is 15 degrees apparently. That figure is not really important, but the point that's important is that the surface, so the soil, ground that we walk on, gets warmed up first. And then the next point, the surface radiates heat back towards space in the form of infrared ray. Okay? But certain gases in the lower atmosphere can absorb certain wavelengths, and this wavelength being IR spectrum, infrared spectrum. They can do this by storing energy in the molecules by stretching and then bending. Only polar molecules apparently can do that, but then non-polar molecules like carbon dioxide and methane can still be moving faster because they can get excited by the certain wavelengths, infrared. This table shows the common greenhouse gases and also how it affects the temperature of the Earth's atmosphere. Without having carbon dioxide, small amount, and also even some methane gas, Earth wouldn't be able to keep its temperature, I think 3 per million, 3 million. They need to be able to be fairly small. Let me just show that. Yep. There you go. Table. This thing is called natural greenhouse effect. The carbon dioxide is necessary for the Earth to have the main warm temperature. Some common greenhouse gases, which are carbon dioxide, methane, and nitrous oxide. Main sources where carbon dioxide can come from is burning of the fossil fuels, anaerobic breakdown of plant material for methane, and denitrification of nitrates by microbes, so that happens in the soil. So what comes out from the main sources would be fine, but then we've got this human activity. So transport, power destruction of rainforests produce more carbon dioxide than what the main sources of carbon dioxide yeah, would be. And for methane gas, rice growing, cattle and sheep farming, they all make methane gas. Use of fertilizers produce more nitrous oxide in the air, and that's going to be bad because you can, next page, yeah, change the thermal balance of it. All right. So this diagram here is showing how greenhouse effect occurs. Some are good, some part of this is bad, some is natural, some are caused by us. So make sure you can describe what's going on with heat, and that's coming out from the sun, but how it's retained within the atmosphere. There is one called CFC gas, yeah, coming out from the spray can. CFC gases used to be used for aerosol cans, with spray cans, because it was cheap and I think it was very easy to use, compress and stuff. And as a coolant for air cons and fridge as well, it was used for quite often. But I think it's banned now because they found that it not only breaks the ozone layer, because it causes a chain reaction in ozone to become oxygen. We want the ozone layer at the top in high altitude, but in a lower atmosphere, it also was found that it is much more potent greenhouse gas even compared to carbon dioxide or methane. So yeah, it's not used anymore. Now at this stage, you should be able to do question 1 and 2, but I'm gonna just move on for the purpose of this video. So we will also talk about some C concepts. We'll look at some documentary, maybe from Cosmos, not this inconvenient truth that it's written. That's okay. We'll also look at the thawing permafrost. What is permafrost and how it's being affected and thawing, so melting away, and how it contributes to greenhouse effect. In this slide, you see what's called the Keeling curve. I think it was Dr. Keeling who managed to find a method of accurately measuring carbon dioxide in the atmosphere over the years, and yeah, put all the stats together to make that curve. So we have got very good accurate data since 1958. And we'll have a discussion on this one. How could it be anthropogenic, which is human influences that cause this change? So you can see that carbon dioxide concentration in the air, in ice, that they, I think, used to measure that, have changed from very low amount, or shouldn't say low, but much lower to where it is now. If you read page 7 of Essentials workbook, you can find pretty good information about it too. Next slide. Global warming, some more knowledge and understanding that you need to be able to have. Yeah, some of the common greenhouse gases help maintain steady temperature in the atmosphere, but water, ozone, and halocarbons also contribute. So anything that we make, we produce, we introduce to the atmosphere affects human activity. That affects the concentration of greenhouse gases, has potential to disrupt the thermal balance of the atmosphere by increasing the concentration of greenhouse gases. Important thing is human activity, and which disrupts the thermal balance of the atmosphere. This is known as the enhanced greenhouse effect. Enhanced greenhouse effect causes the global warming. What are the consequences for the environment? Which is what you need to be able to explain, which was asked in the first table. So please look at Essentials workbook, page 9 to 11. If you look at headings under consequences for the environment, you should be able to note down, pick out 4 different effects and explanation to it. So I make brief notes about each one of them and how it occurs. And yeah, one more thing would be this. yeah, we'll be sharing, or we're looking at this chart that you see, diagram that you see, and also the Bureau of Meteorology's website to look at what stats we are seeing and how real it is to have this greenhouse effect and how it's disrupted by us, so that we can examine plot trends in global concentration of carbon dioxide, sea surface temperature, and air temperature. After that, we'll do more question 3 there. That's it for this video, I believe. Yeah, we'll talk about ocean acidification in the next video. All right.